Hey everybody, this is 7.2, Day 2, Part 2. So in this section of our lesson, we're going to spend some more time doing different types of simplifying, and then we're going to also learn how to rationalize a denominator. So first of all, just continuing with the simplifying. Remember, when I have a fraction underneath a radical, I can split this up and turn it into the fourth root of x to the fourth divided by the fourth root of y to the eighth. And now I can use the properties we learned on the previous page. So on top, the fourth root and the power of 4 just cancel each other. And on bottom, in my mind, I'm thinking 8 divided by 4, which gives me a power of 2. So x over y squared is my final answer. Problem E is going back to some simplifying with radicals. So this is a problem where I want to simplify. It just looks complicated because I have some fractions going on. So here's what I'm thinking first of all. 6 divided by 2 is 3, all right? Then I'm going to right away take care of this z down here. Z to the negative fifth. So that's going to move that to the top. Now I'm going to think about my x's, and notice I have x to the first on top, x to the 1/3 on bottom. I put that 1 there, but we all know if there's no exponent, it's like x to the first. So in my mind, I'm thinking top power subtract bottom power, and 1 subtract 1/3 is 2/3. So x to the 2/3 power. And then, you know what? My y has nobody to combine with, so y to the 1/2, and there doesn't actually end up being anything left on bottom. So 3 z to the 5th, x to the 2/3, y to the 1/2 is my final answer. All right, let's look at F. And you know, let me tell you, at any point during this video, you can just pause and try these on your own first and then come back and watch to see if you did it correctly. But for part F, I'm just going to right away start thinking about simplifying. So the first thing I'm thinking about is the a's. I've got the fifth root of a to the fifth. Well, that cancels out and I'm left with a in front. And by the way, I didn't touch the 5 yet. If I try to do upside down division on 5, nothing happens. So that can't be simplified at all. So I know that that 5 is just going to be underneath the radical for my final answer. Now I'm going to look at my b's. So I've got the fifth root of b to the 9th. And I'm going to use that shortcut I taught you where we're going to do the inside divided by the outside. So in my mind I'm thinking, okay, 9 divided by 5. It goes into there once, with 4 left over. So I've got b to the first outside and b to the fourth inside. And another way you can think about it, remember, if you want to, just write it out a little bit longer hand, and I get b to the fifth times b to the fourth, because 5 plus 4 is 9. And then I can think about it like this. So that fifth root of b to the fifth cancels out to be b, and then that part stays underneath. All right, my c's are next. I've got the fifth root of c to the 13th power. For this one, in my mind, again, I'm looking for groups of 5. So if you want to, you can write it out like this with groups of 5, or you can think 13 divided by 5. So whichever way you do it, there's 2 sets that can be pulled out, so I'll say c squared outside, and then there's c cubed left underneath that can't be simplified. And remember, you know you're done when the inside power is smaller than the outside root. This is my final answer. Moving right along, part G. So here's what's happening with part G. I'm going to split this up into cubed root of x divided by the cubed root of y to the 7th. On top, I'll just leave that cubed root of x. On bottom, I'm thinking in my mind 7 divided by 3, or I can think y cubed, y to the first, because 3 plus 1 is 7. And either way, I end up with y squared outside, and I end up with the cubed root of y underneath. And by the way, this is not fully simplified, but we're actually going to learn about how to make it fully simplified in example 6. So for now, we're just going to leave that one as is and say that's our final answer. All right, H is going back to that easy problem where if I've got the same exact variable, I can just subtract them. So negative 5xy to the 1/3 is my final answer for H. And for I look at this and it does not have the same variable. Now, if that situation happens, most likely your textbook is just trying to make you think a little bit. So we're going to take this and simplify it, and we can almost guarantee it's going to end up being the same as this variable when we're done. And actually, you know what? Now that I think about it, I notice that I have an x to the 5th underneath that cubed root, so that means that can also be simplified. Alright, so let's do this part first. So the 5 stays underneath, and then I have the cubed root of x to the 5th. So I'm thinking 5 divided by 3. It goes in there once, so I pull x to the 1st outside, and then I've got x squared left. That 3 was just still there from before. And now for this other problem, I'm going to think upside down division on 40. I'm going ahead and dividing away. I end up with 2 square root of 10 for that. So there's a 2 outside now, and that x is just there. That's not x cubed. That little 3 is going with the cubed root here. So now I've got 10 left over underneath because 2 times 5 is 10. And then the cubed root of x squared, I can't simplify that because 2 is a smaller number than 3. And now this is kind of confusing, but notice what happened was this part is the same variable. Actually, it was supposed to be. I must have done something wrong. Oh, you know what I did wrong? Because it's a cubed root, I was supposed to be looking for groups of 3. Sorry, class. Because I looked for a group of 3, I only had 5 left over. Alright, anyways, now I've got the same variable underneath, and notice that this part right here also is the same. I've got 3x and I've got an x here. So now I can think, okay, I've got 3x of those things, subtract 2x of those things, so that is 1x of the cubed root of 5x squared. Kind of crazy, but that's my final answer. Alright, we're to our final part of section 7.2 finally, and this is about rationalizing a denominator. So, to start off with, I want to do a review from Geometry 2. You've learned this before. A regular simplifying or getting rid of a denominator, that's a radical. Basically, I don't want that to be there for it to be fully simplified. What I'm going to do is I'm going to multiply by the square root of 2 over square root of 2. And that is legal because the square root of 2 over square root of 2 is equal to 1. So really I'm not changing the value because anything times 1 is just itself, but this will let me change how it looks. So now that I'm thinking this, I'm going to multiply straight across. So 1 times the square root of 2 is square root of 2. And then on bottom, square root of 2 times square root of 2 is square root of 4, but that's a square root we know. So the shortcut is, if I know I'm square rooting this, that times that's going to just be 2. It works the same way, but a little bit different when I've got a cubed root or a fourth root. So that's kind of the new thing that we're learning in today's lesson. So when I look at this, part B, I've got a cubed root of x. So the thing is, in order to cancel out a cubed root, I need x to the 3rd power. So instead of just doing a single cubed root of x, I'm going to need 2 different cubed root of x's in order to make it x times x times x, which is x cubed. So right now I've got x times x times x is x cubed on bottom, so the cubed root of x cubed. On top I've got 4 times the cubed root, and then x times x is x squared. So what this does for us is that the cubed root and the cube cancel each other, and so I'm left with 4 cubed roots of x squared divided by x. And again, my whole goal is to make it so that there's no radical on bottom. Now, as a shortcut to this right here, I'm going to show you with example C. If I know I need 2 more of that thing to cancel out the cubed root, like if you look at C, it's again a cubed root, so I need 3 5s multiplied together in order to cancel out the root. So if I know that's the case, I can kind of make a little shortcut for myself, and I'm going to multiply by them together under the same parentheses, or not the same parentheses, the same radical. That way I don't have to write as much. And I didn't have to say 5 times 5, I could have said 5 squared. I'm just trying to simplify it for you this first time you're learning it. Alright, from what I learned before, remember, 5 times 5 times 5 is 5 cubed. I know that that's going to cancel out and just be 5, so let's just say that right away. And then on top, 2 times 5 times 5 is 25 times 2, which is 50. And we would simplify that cubed root of 50 if we could. Turns out being that the cubed root of 50 can't be simplified because there's nothing that I could pull out that's a group of 3. If you really want a challenge, pause the video and try D and E and F at this time. Otherwise, just keep listening. Okay, when I look at D, what's happening here is that, again, I can split up. If I've got a fraction underneath a radical, you can split it up until top and bottom. So actually that's kind of nice because the cubed root of x cubed just becomes x. And now notice on bottom, remember how I said you need to have y cubed or something cubed to cancel out a cube root? I already have y squared, so this time I only need one more y in order to make it y cubed. So this time I just need to multiply by a single cubed root of y. I don't need to do two of them because I just need 3 y's total. I don't want 4 y's total. Alright, so on top I got x times the cubed root of y, and on bottom, so the reason I did that is, if I wrote it all out, I got 3 y's multiplied together, which is y cubed. So the cubed root and the cube cancel each other, and I just am left with y on bottom. So my point here is that it's best if you try to simplify as much as possible first, then rationalize. So right now, I don't want to start right away by multiplying through by this. I want to simplify it first to make my life easier. So first I'm thinking, okay, cubed root of now I'm doing square roots again. So square root of 9 is 3. Square root of x squared is x. Square root of y can't be simplified. On bottom, square root of 32 we don't know, so I'm going to do some upside down division action. I end up with 2 groups of 2 and 2 left over. So 2 times 2 outside, and then 2 left underneath. For the z cubed, I've got the square root of z cubed. So that ends up being a z outside and a z left over. Okay, once I've gotten to this stage where it's as simplified as I can make it, that is when you want to rationalize it. That will make your life easier later. So now I'm at this point where I can't simplify anything else on bottom, and so I know it's a square root, so I only need one more of them to make it cancel. I'm going to just multiply then the top and bottom by the square root of 2z. Now this is a little weird, but notice, remember, the stuff outside stays outside, and the stuff underneath can be multiplied together. So on top, I can multiply together that y and that 2z. And let's just think critically for a second here. I know that 4z is there. That just carries over from before. But what happens with this part is the question. So here's what I'm thinking in my mind. Just quick side note. 2 times 2 is 4. Z times z is z squared. Okay, square root of 4 is 2. Square root of z squared is z. So that whole part simplifies to 2z. So you could have just done that one step if you wanted, but now I'm seeing 4 times 2 is 8. Z times z is z squared, and the top part I haven't changed. So that is my final answer. Alright, part F lets us really think critically about how many of a number we need in order to cancel out a root. And this time, see, I've got a 7th root. And you always go off the bottom root because that's the one we're trying to cancel out. For a 7th root to cancel, I need something to the 7th. So right now in my mind, I'm thinking, okay, what power of x do I need to put here to make it so it's x to the 7th? And I currently have x to the 4th, so I need 3 more basically. So I'm going to multiply the top and bottom by x cubed. Now, math fact for you. You cannot multiply together radicals if they do not have the same root number. So I have the 5th root of x cubed times the 7th root of x cubed, and those actually can't be multiplied. But on bottom, that whole thing ends up being the 7th root of x cubed like I wanted it to, because now it's just x on bottom. And that's it. This is a very tricky section, so we're going to work a lot during class, but I'm sure you'll have questions for me. Make sure you write them down on your sheet, and we'll talk about this thoroughly when we get to class. Thanks, guys.